We are here on this fine day to experience a wonderful game of baseball featuring Dartmouth versus Yale. Right now we are a little bit into the game and Yale is winning. Something to make this game really exciting is talking about the physics. Without physics we wouldn't be able to understand what's going on. But don't worry, we'll explain it to you so it's not confusing.
As the batter runs to first base, he wants to stop right on the base, but since he can't start slowing down earlier, he has to run at full speed until he hits the base. Why can't he just stop when he hits the base? Because of inertia. Inertia is the natural tendency of an object to keep going or stay at rest in a constant straight line. Since he has more inertia, his body wants to keep going. Also, friction plays a role into this because if the ground has had less friction with his shoe, it would take him longer to stop because friction between the two objects slows them down.
Here, the batter has just scored a triple, and right after he realizes that he speeds up. He first travels at a constant speed, then gains speed or positive acceleration, and when he gets closer to third base, he starts to slow down or have negative acceleration. Here is what his path looks like.
When the pitcher winds up, he is doing two things to help him. One, he is hiding the ball with his legs so no one can see his throw and getting more force by using his whole body. The ball is released at just the right angle so that it's directed down instead of up. Over the horizontal distance, the vertical height changes.
For a baseball player, you need to have a quicker reaction time than normal, because if you are late, you will strike out.
To find the acceleration and force required to throw the ball, we must use equations. First, we know the distance from the plate to the mound is 18.4 meters, and it takes about 0.45 seconds to get to the plate. We use the formula V equals change in distance over change in time, and we get 40.8 meters per second for a velocity. Now to find the acceleration, we do A equals velocity over time. To plug in the velocity and the time, we get 90.8 meters per second squared for an acceleration rate.
Now to find the force required, we do F equals ma, which is Newton's second law. Acceleration of an object is proportional to the force applied on it, and inversely proportional to the mass. We know the mass of the baseball is about 0.145 kilograms, and the acceleration is 90.8 meters per second squared. So we plug the numbers in and get a force of 13.2 newtons to be applied on the ball.
Here, when he slides into the base, it's an example of Newton's first law. An object in motion remains in motion unless acted upon by an outside force. When he slides, the outside force is friction between him and the ground, and he would keep sliding if the ground didn't stop him. Even when he stands up, he is still moving.
Now let's talk about energy. During the ball's journey, energy is being transformed. When the pitcher is winding up, he's gaining elastic potential energy in his leg, and then has potential energy in his arm and legs, and then it goes to his fingertips where he releases the ball, and the energy is being transformed to the ball with kinetic energy. As soon as it leaves the hand, there is friction from the air that slows it down. The kinetic energy transformed into gravitational potential energy when it is in the middle of the throw, and goes back to kinetic energy right before it is hit by the bat.
There's potential energy in the swing that is built up from the knees and the arms. When the ball hits the bat, and there's potential energy in the bat being transformed to kinetic energy to the ball again. The ball has gravitational potential energy and the kinetic energy as it is flying. If it is caught, the energy is released into the mitt and hand. There's equal force on the ball pushing on the mitt as the mitt is pushing on the ball, which is Newton's third law. If the ball is thrown and hits the ground absorbs the energy and the ball slows down due to friction.
Thanks for tuning in to the Ivy League Baseball Sports Network.
Hope you learned a lot and enjoyed the game.